See the sixth one. Find the intervals in which the following functions are strictly increasing or decreasing, correct? So we are trying to figure out what is the interval. So we have already done one sort of like an interval type of question, very similar to that. So the first one, minus 2x cube minus 9x square minus 12x plus 1, right? Differentiate. When you differentiate f dash of x, this is going to become minus 6x square minus 18x minus 12. Equate this to 0. You can divide by minus 6, right? You'll get x square plus 3x plus 2 is 0. Or you can write this as x plus 2 into x plus 1 is 0. Remember splitting the middle term type of questions. So what are the values of x now? So x is either minus 1 or minus 2, right? So what do we have? We are going to have 2 points here. Very important, 2 parts we are going to take. So imagine this is your number line. Okay. 1, minus 2, minus 3, so on and so forth. First we'll do from minus 1 and greater than minus 1. Any value greater than minus 1, if you are going to substitute, see what you have x square plus 3x plus 2, right? So this is your f dash of x. Remember, this is your f dash of x. See, since you have f dash of x here, substitute 0. If you substitute 0 or any value which is greater than minus 1, you are going to have a positive value. That means this part it is increasing. Correct? So this is increasing. Now any value less than minus 2, any value. Like say you take minus 3, minus 4, anything. Let's take x as minus 4 and check. Suppose if x is minus 4, this value is going to give me minus 16. Sorry, 16 minus 4 square is 16. Then minus 12 plus 2, which is still positive. That means this is also going to be increasing function. Right? Now, in between, when you do it, in between, that is from minus 1 to minus 2. Say you take minus 1.5, something like this. So if you take minus 1.5, so you will have, that's minus 3 by 2. Minus 3 by 2 whole square is 9 by 4. Then plus 3 into minus 3 by 2. Correct? So minus 9 by 2 plus 2. Right? So 9 by 4 minus 9 by 2. 9 by 4 minus 9 by 2 is minus 9 by 4. So you have minus 9 by 4 plus 2, which is going to give us minus 1 by 4, which is negative. That means in between we have a decreasing value. So what do we get? Anything more than minus 1 is positive. Anything less than minus 2 is positive. In between we have negative. Isn't it? This is what we have. So we have increasing function, we have a set of interval. Decreasing function, we have an interval. So let's write down the interval for which it's increasing and decreasing. All right. For the increasing part, we have from minus infinity to minus 2 union. Okay. So this is the answer for the first one. Fine. Let's do the second one now. Very similar to this one. All right. See the second one. 6 minus 9x minus x square. Differentiate. When you differentiate, f dash of x becomes minus 9 minus 2x. Right? or equate this to 0. So when you equate it to 0, you'll get 2x plus 9 is equal to 0. X is equal to minus 9 by 2. Right? So now again, so you're going to take the number line. This is 0, 1, 2, 3, minus 1, minus 2, minus 3. Okay, so minus 9 by 2 is minus 4.5, isn't it? So I think it's better if you take the numbers a little bit this side. All right. Say this value, we'll call it as 0. 1, 2, minus 3, minus 4, minus 5. Say this is 1. Now minus 4.5 is somewhere here. Correct? Minus 9 by 2. Now we'll take any value greater than this. Maybe like 0, minus 1, 1, whatever you can take. Okay. Say we'll take a value of x as 0. Alright, if x is 0, then f dash of x. Suppose if x is 0, then f dash of x, or you can say f dash of 0, this is going to become minus 9. Right? This is going to become minus 9. So when f dash of 0 is minus 9, is it negative or positive? It is going to become negative. So this part is going to be decreasing. Alright, then anything less than minus 9, say you have minus 5 or minus 6 or something like this. Say minus 5 you have. Simple number, say minus 5. When you have minus 5 here, f dash of minus 5 becomes minus 9 plus 10, which is 1, which is going to be increasing. Alright, so for the second part, the increasing part is going to be minus infinity to minus 9 by 2. This is increasing, correct? And for the decreasing, it's minus 9 by 2 to plus infinity. This is for decreasing. So we got the answer for second one. Let's do the third one, that is 6C now. See C part now. Now you have x plus 1 whole cube into x minus 3 whole cube, right? Differentiate. If dash of x is equal to 3 into x plus 1 whole square into x minus 3 whole cube plus 3 into x plus 1 whole cube into x minus 3 whole square. So this is the value. Now we'll equate it to 0 and get the points. Alright. When you equate this to 0, alright. Right? Either x is 1 or this value is 0. That means in this first part, when you take it, you can take x is minus 1 or x is 3. X is minus 1 or x is 3. So now we have 3 points. We need to look at these 3 points and then we need to go about it. Understood? So let's draw the number line and do it. Rashmi, ನಾನು ಹೇಳ್ತಿದ್ದ just comment ಇದು because we have 3 minutes. 3 minutes till I need to finish it. Now we have 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, now the first point what we'll take x as 1. Okay, so this is 1 point. Another one is minus 1, correct? And another one is 3. So we need to take 3 intervals. So first we'll do from minus 1 to infinity, minus 1 to 1, 1 to 3, 3 to infinity. Correct? Now when you're doing this, see what you're going to get. The first part, when you apply the value. So when you apply the value, you have x plus 1 into x minus 3 whole square into, you can write 2x minus 2, right? Apply value of, say, x is equal to negative 2. This, so minus 1 to 1, say you take a value of 0. If it is 0, this is positive, this is negative, this is also decreasing. Okay. Now the next one, 1 to 3, 1 to 3, take any value, this is positive. Say you take a value of 2, this is positive, so it's increasing, this is also increasing. So these are the intervals. All right, so let's do the next one.
Function, how do we declare what is a decreasing function? And are there any functions which are neither increasing nor decreasing? That's what you're going to learn in this particular video. That is, what exactly is an increasing function? What exactly is a decreasing function? Understood? So let's talk about different types of functions. I mean, when I say types of functions, don't go into the first chapter where we talk about bijective, that, this and all. We are not talking about that. Okay, so here we are specifically talking about, is the function increasing? Is it decreasing? If it is increasing, how do you tell it whether it's increasing or not? All these things we are going to discuss in this particular video. All right, now let's discuss about what are the types. When I say types, talking about increasing, decreasing type of functions. All right, let's discuss about those types now. When we talk about these increasing, decreasing function, all right, so the first type, you can say increasing function. Okay, just increasing. Now, in this case, suppose say you have two values, x1 and x2. Okay, so assume that you have x1 and x2, and they are there in such a way that x1 is less than x2. Clear? x1 is less than x2. If f of x1 is less than or equal to f of x2, then we say that the function f of x is increasing. Understood? Let me, and f of x1 is less than or equal to f of x2, then we say it's increasing. So what do we write and how do we go about it? A graph. Maybe you can say something like this one. See, like this. See, something like this. Still increasing. But f of x1 is equal to f of x2 at one particular point. But overall, the function is still increasing if you're going to look into it. Correct? So these are what we call as increasing functions. Next in increasing itself, we have one more type, what we call as strictly increasing. Okay, let's look into what is a strictly increasing function. Right? In this strictly increasing function, when you have strictly increasing, you have x1 less than x2, some value of x1 and x2, and f of x1 is strictly less than f of x2. There is no slack inequality, there is a strict inequality. That means now, say this is your graph. Let's say your graph is going to go something like this. There is no equal value anywhere. Anywhere in the graph, you're not going to have f of x1 is equal to f of x2. Fine? This is what we call as a strict decreasing function. See now, decreasing function. See, decreasing function in the sense, you have x1 less than x2. Okay, so you have a smaller value. Whereas f of x1 is greater than or equal to f of x2. Like in our example itself, that parabola we took it, no? So minus 2 and 0. Minus 2 was less than 0. Whereas f of f of x1 is greater than, sometimes equal to also. Sometimes greater than or equal to f of x2. So this basically is what we call as decreasing function. So here you can think of an example like this. See something like this. So here, this is the value of x1 and you can say this is the value of x2. x1 is greater than x2. Or if you are going to take some value x3 here, so whatever we are looking at is decreasing. Now you must have, you must have already thought about it. The next type of function is a strictly decreasing function. Alright, so we are going to understand about what is a strictly decreasing function now. See, in a strictly decreasing function, so here what we have, x1 is less than x2, but f of x1 is understood. So in the sense here we are going to have a graph which is maybe something like, see, like this. Maybe something like this one. Fine. Maybe e power minus x graph. You can think of something like this. So this is a strictly decreasing function, increasing nor decreasing. Okay, like that parabola, that is one of the examples. Okay, we'll discuss what is what in that one. All right. See, the next type of function, we have neither decreasing nor increasing. It's like both. Fine. The parabola is a beautiful example. So here you have, here you're going to have the y-axis and x-axis, and you have a graph like this. Some parabolic function basically. So here x1 can be less than x2. F of x1, sometimes it is less than f of x2, and sometimes f of x1 is greater than f of x2. So this is the reason why we tell that these are neither increasing nor decreasing function. So it neither goes up nor comes down, or it can happen both. Like if you take an example of sine curve. See, if you take an example of a sine curve goes like this, correct? It's increasing, decreasing. This is one possibility. Or the parabola where it decreases then again increases. So there are multiple functions which are neither increasing nor decreasing. So these are different types of functions. Now the chapter or the topic name is application of derivatives. And here we are looking at functions. It's increasing, decreasing and all. Let's understand how we use the derivative to understand this one. Alright. See, now let's do the derivative part. That means say you have a function f of x. Okay, function f of x is continuous in a comma b and differentiable in a comma b.